We're looking at the 2.8 guided notes. Bye, Valine. Good luck. The 2.8 guided notes is about graphing linear inequalities and absolute value inequalities. And really, there's only one main difference, or two main differences here, shading and whether or not it's a solid or dotted line. And we'll get to that in practice. So, here, let me make sure I get my pen. All right. A linear inequality resembles a linear equation, but with an inequality symbol instead of an equal sign. So here's our example. Linear equation is y equals negative 3x minus 2. And this is in mx plus b form, right? Our slope-intercept form. Here I have a linear inequality. Instead of y equals, I have y is greater than negative 3x minus 2. So if we wanted to graph this, I can graph this equation, right? Count or find my plot my y-intercept and count my slope. So let's just go ahead and do that here. Here, negative 2, hit negative 2, and my slope is negative 3 over 1. So I count down 3, 1, 2, 3, and over 1 unit. And here I am. This would be my line that goes through these 2 points. Now I want to finish off the notes just below it here first. So when graphing linear inequalities, we need to determine if the boundary line, we're going to call this a boundary line, is dashed or solid. This is the same process as determining if it's an open or closed dot on a number line. Then we use a test point, to determine which side of the graph we should shade. Now, so open dot is less than and greater than, so this is going to be our dashed line. The closed dot, that's the less than or equal to, greater than or equal to, and this is a solid line. Okay, so if we're going to graph this, I know it needs to be a dashed line. So I'm going to get my dashed line out here. So, goes that way forever. Okay, so now we have our dashed line. And now I needed to use a test point. So I want to use a test point to find out if I should shade on this side or on this side over here. So the easiest test point to use is the origin. So we're going to try the point. We're going to try the point 0, 0. If I plug in 0, 0 and it's true, then I'll shade towards the origin. If I plug in 0, 0 and it's false, then I'll shade away from the origin. So let's just see. Here's my y value of 0. So I'm going to say 0 is greater than or equal to negative 3 times 0 minus 2. Cleaning this up, I get 0 greater than negative 2. Is this true? Well, sure, it's true. So then I want to shade on this side. And I don't need this to be perfect. Just let me know that this is the region in which we are shading. So anything like that would be suffice. I just don't want to get too close to the line because I failed kindergarten when it said has the ability to draw within the lines. I never did. So here we have completed the graph of this linear inequality. That's how we graph a linear inequality. And note, the line, the boundary line, here's my boundary line. My boundary line is the equation y equals negative 3x minus 2. So that's really all I did is I graphed the line y equals negative 3x minus 2. But note, this is the linear inequality where I needed to determine if it's a dotted or solid line. and then used my test point to shade one side or the other. So there's just two extra steps about solving or graphing, a linear inequality. So this idea here of having a dash line, or a solid line, and using a test point to determine which side we should be shading or which region we should be shading. The same exact method is used when graphing absolute value inequalities. Now, we already know through transformations of these absolute value functions, we know for sure that this graph that goes down 2 units here, right? So my vertex is 0, -2, and my a value is 1, which tells me it goes up 1 over 1. And on the left side of my line of symmetry, I'm going to have my other point here. So these are my 2 points. Now, since this is less than or equal to, I'm going to use a solid line. I'm going to use one with an arrow. How about that? How do you like me now? All right, so it's going to go on forever in that direction. It's going to go on forever in that direction. Boop, there we go. And now I need to determine, am I going to shade above or below down here? So I'm going to use my test point. I'm going to use 0, 0 again. I'm going to say, whoa, not that part. I need that. Is 0 less than or equal to 0 minus 2? Just clean that up a little bit. 0, is that less than -2? Well, no, it sure isn't. So I shade away from the origin. I will be shading this region here. All of the xy ordered pairs that are in the blue region here, all of these xy ordered pairs are solutions to this inequality.